This is my analysis of the study on optimal polyandry in fruit flies, Drosophila melanogaster, by Yan, Rosenbaum, Yang, and Dukas. This study was motivated by a broader interest in understanding the evolutionary benefits and the potential drawbacks of polyandry, which is where females mate with multiple males. Polyandry is common in many species, including fruit flies, yet its adaptive advantages are not fully understood. Although mating with multiple partners can increase genetic diversity and reproductive success, it can also expose females to risks, such as energy depletion, disease, and increased harassment by males. The researchers aim to clarify how polyandry influences female fitness, particularly by separating the effects of this frequent mating from those of male harassment, which often has confounded results in similar studies that have been run. So the researchers hypothesized that higher mating frequencies would benefit female fruit flies by enhancing their reproductive success, but only to an extent that wouldn't compromise their overall health and their lifespan. They also predicted that female fitness would peak at a certain optimal mating rate before either leveling off or declining if mating became excessively frequent. Testing the fitness consequences of at least 3 levels of mating would reveal novel insights about optimal polyandry. So as you can see here, this diagram displays two curves. Curves 1 is a decelerating increase where it levels off, and curve 2 is where it decreases in fitness after a certain mating rate. So before I go over the results, I did want to include that the researchers included an ethical note in their research about that their research did not require formal approval from an ethics committee, but they treated their subjects in accordance with animal ethics standards under the assumption that they experience emotion and pain. So if you look here, A shows that the mating rate ranges for each of the conditions, B shows the similarity in survival curves, and C shows that offspring per female increase proportionally into the increase in polyandry. So the study's controlled traits revealed that female fruit flies experience the highest fitness at high and medium mating rates, mating every 2 and 4 days respectively. Even under these frequent mating conditions, they did not experience a decrease in lifespan, which suggests that these high rates can confer fitness benefits without substantial costs. So females are more fit because they can produce offspring at no cost to their lifespan. So these findings have significant implications for understanding sexual selection. They suggest that polyandry could drive evolutionary changes in female traits, potentially influencing secondary sexual characteristics, which are traits that are not directly tied to reproduction, but helpful in mate attraction, similar to a peacock's feathers. Additionally, frequent polyandry can intensify sperm competition among males, potentially affecting male evolutionary strategies and influencing reproductive dynamics within populations. So this study has been very, very influential, and this could apply to not just fruit flies, but many other species as well. So thanks for listening.